To solve this now, the solution will be change in G is equal to change in H minus T change in S. Now, change in H is the entropy change, which is 89 kilojoule. So, and the T is the temperature, while the entropy change is given as 11.89 kilojoule. So, that taken, we have change in H. Change in H is 89 kilojoule per mole minus T temperature, which is 25. We convert it to the absolute scale by adding 273 to it, times entropy change. The entropy change is 11.89 kilojoule per mole. Kilojoule per mole. So that is 89 minus 298 times 11.89. So this gives 89 minus this times this. So let's do 89 minus 298. We compute 298 times 11.89. 298. That will give us 3516.4. 3516.4. So 89 minus 3516.4 is equal to, we compute that now, that will give us minus 3427 minus 3427.4. So change in G, which is the free energy, is given as 3427.4. So this is the final answer. So when you are giving a question like this, you will ensure that the units are the same, especially in kilojoule. So if one of them is in kilojoule and the other one is in joule, it will be safe for you to convert everything to joule. Or if it's in kilojoule, you convert everything to kilojoule. So preferably convert everything to kilojoule, so be on the safe side, on the safer side. So, but this is now, both of them are on the same units. So they have the same units, so no need of conversion. So once the change in G is negative, it means there is a spontaneous reaction. But assuming the change in G is positive, it means there is no spontaneous reaction. The reaction has to be powered by an external energy. But if the change in G is zero, then what it means is that the system is at equilibrium. So please understand that sometimes the questions you will have will be, what is the meaning of the notation? We have several notations. So like I've mentioned before, so we have several notations that you could be asked to give the meaning of to give their meaning. So for example, now this one here is change in heat of combustion, then change in heat of neutralization, then change in heat or enthalpy change. So you just have enthalpy change. Then this one is entropy change, that is the degree of disorderliness in the system. So then this one is change in G, which is the free energy, that is the energy available for the reaction to take place. Then we now have the change in age. In most, you have a relationship for calculation where in most cases they ask you what is the change in age for a particular reaction. So to get that kind of to get the calculation right, you have to remove the heat of formation of the product. You have to remove the heat of reactant from the heat of the formation of the product. So the entropy, the same thing. You remove the entropy of the reactant from the entropy of the product. Then you do the same thing. You now have a relationship for entropy change, which is the change in H over T. Then and the T must be in absolute scale, and that is Kelvin scale. So it will be in Kelvin scale. Then you have change in H, which is change in G, which is the free energy. That is the change in the heat of formation or enthalpy change minus the temperature, absolute temperature, multiplied by the change in entropy. So that is the relationship. That is the one we use here now. So that is the relationship we use. Then let's now look at another one, like this question number 2. So this question number 2, you give a relationship. To solve this, the question is asking calculate change in S, that is the entropy, for the conversion of 1 mole of liquid water to vapor at 100 degrees Celsius. Given that the heat of vaporization of water is 22,260.89 joules per gram. So now, what you do is you start by noting the heat of vaporization, which is given to us. Vaporization is equal to 2260.87 joule per gram. Then mole of water, mole of H2O is equal to 18. That is the molar mass of water. So to get the change in H now, which is a parameter we are going to use, is going to be 18 times 2260.87 joules per gram. So that is the relationship we are going to use. Then we compute this. If we compute this, the answer will be 4695.70. So this is going to be in joules per mole now. Joules per mole. So this is what we have as change in it, but this is not the final answer. The answer is asking us to calculate the change in S, that is the entropy change. And to get entropy change, we have a relationship that says change in entropy is equal to the change in heat of formation or the entropy change over temperature, that is the absolute temperature. So this is the relationship we are going to use. And to compute this now, we have gotten our change in H, then we have the temperature. The temperature was given to us at 100 degrees Celsius. So what do? We compute this to have 4695.70 joules per mole over temperature, which is we will convert to absolute scale now. We have 273 degree Kelvin to it. So this will give us 4695.70 joules per mole over 3 73 degree Kelvin. So this is now going to give us, if we compute this, it's going to be 109.10. 109.10. So it will be Joule per Kelvin per mole. Joule per Kelvin per mole. So this will be the final answer. So 109.10 times 109.10 joules per Kelvin per mole. So we are relating the temperature to it. So that will be the final answer to that. Now we have some other relationship that could be had in examination conditions that are mainly theoretical. So the questions like the conditions or factors that determines spontaneous reaction. So we have three major factors. Number one is the enthalpy. Number two is entropy. And number three is free energy. So these are factors that affect spontaneous reactions. So you have the enthalpy, which is the change in H. Then you have the entropy, which is the change in S. And you have the free energy, which is the change in G. Now, a relationship that combines these three is what we determine as change in G is equal to change in H minus T change in S. So that is the free energy is equal to the change in the heat of formation or the enthalpy minus that absolute temperature and change in the entropy of that reaction. So this is a relationship that happens. So from here we can even make any of the necessary formula, and in case you are having a question that relates to this. So please, this is one of the most important formula for thermodynamics. So we solve other one and we will see how we relate those ones. So please subscribe to the channel if you have not done so. Thank you.